Ever built an amazing LLM app, only to see it hallucinate nonsense in production? You're not alone. The secret to grounded, reliable AI isn't just a better model. It's a robust Retrieval Augmented Generation, or RAG system. Deploying RAG isn't just about chaining a vector database to an LLM. It's a multi-stage pipeline fraught with potential pitfalls that can tank your user experience and trust. Getting it wrong means frustrated users and wasted development cycles. By the end of this video, you'll have a clear, actionable checklist to confidently ship your RAG application, ensuring it's accurate, scalable, and truly valuable. Chapter 1. The Core RAG Loop, a quick refresher. Before we dive into production, let's quickly recap what RAG is. At its heart, RAG is about empowering large language models with external, up-to-date, and domain-specific information. This fundamentally addresses the LLM's knowledge cutoff and tendency to hallucinate when it lacks specific facts. The process involves two main stages: retrieval and generation. First, a user's query triggers a retrieval mechanism, which searches a vast knowledge base, think documents, databases, web pages, to find the most relevant pieces of information. This isn't just a simple keyword search. It often involves semantic understanding. Once those relevant documents are found, they're passed as context to a large language model. The LLM then uses this specific context, combined with its own general knowledge, to formulate a precise, grounded, and comprehensive answer. This dramatically reduces the likelihood of the LLM inventing facts, making it far more trustworthy. Chapter 2. Data Ingestion and Indexing, the Foundation. Your RAG system is only as good as the data you feed it. The first critical step for production is ensuring impeccable data quality. This means cleaning, normalizing, and structuring your source documents. Are there inconsistencies, duplicates, outdated information? Address these before indexing. Next, consider your chunking strategy. How do you break down large documents into smaller, searchable pieces? Too small, and you lose context. Too large, and you introduce noise. Experiment with fixed-size chunks, sentence-based, or even recursive chunking. Your embedding model choice also plays a huge role here. Align it with your data and domain. Finally, selecting your vector store. This isn't just a database. It's the engine for your retrieval. Do you need high QPS for real-time applications? Scalability for petabytes of data? Consider managed services versus self-hosting. Popular choices include Pinecone, Weaviate, Milvus, and even Postgres with Vector for smaller setups. Benchmark them with your actual data. Chapter 3. Retrieval Optimization, Finding the Needle. Once your data is indexed, the challenge shifts to finding the right information. Basic semantic search is a start, but production RAG often requires advanced retrieval techniques. One common issue is the query document mismatch. Your user's query might be short, while the relevant document chunk is detailed. We've covered the core RAG loop, data foundations, and how to find the right information. But here's where it gets really interesting: making sure your LLM speaks clearly and how to guarantee your system actually works in the wild. This is where query reformulation comes in. Techniques like query expansion, where you add synonyms or related terms, or query rewriting using an LLM to rephrase the user's intent, can dramatically improve recall. Another powerful method is hide or hypothetical document embeddings, which generates a synthetic answer to embed, then searches for similar real documents. But finding more documents isn't always better. You need to re-rank them. After an initial broad retrieval, a re-ranker model can score documents based on their true relevance to the query, pushing the most pertinent ones to the top. Consider hybrid search, combining keyword search, like BM25, with vector search for a robust approach, especially for niche or evolving terms. Chapter 4. Generation and Prompt Engineering, the Conversation. With the right context retrieved, it's the LLM's turn to shine. But simply dumping documents into a prompt isn't enough. Effective prompt engineering is crucial. Your prompt needs to clearly instruct the LLM on its role, the format of the output, and how to use the provided context. Be explicit, Use only the provided context. Choosing the right LLM for your RAG system is another vital decision. Do you need a smaller, faster model for cost efficiency and low latency, or a larger, more capable one for complex reasoning? Consider open-source models like Llama 3 or Mistral for self-hosting, or commercial APIs like OpenAI's GPT-4 or Anthropic's Claude for convenience. Also, integrate guardrails for safety and moderation. The final output format needs to be consistent and user-friendly. Are you expecting JSON, Markdown, or plain text? Specify this in your prompt. For production, consider adding source attribution directly in the response, linking back to the documents used. This builds user trust and allows for easy verification, crucial for critical applications. Chapter 5. Evaluation and Monitoring. Is it working? You've built it, but is it good? Production RAG demands rigorous evaluation. For retrieval, metrics like recall at K and precision at K tell you if you're finding the right documents within the top results. For generation, evaluate faithfulness. Is it grounded in context, relevance, and fluency? Automated metrics are a start, but human evaluation is irreplaceable. Beyond initial evaluation, continuous monitoring is non-negotiable. Track key performance indicators, KPIs, like average response latency, token usage, and user satisfaction scores. Look for drifts in data distribution or embedding quality over time. Set up alerts for unexpected increases in hallucinations or decreases in retrieval accuracy. Crucially, implement user feedback loops. Allow users to rate responses, flag incorrect answers, or suggest improvements. This direct feedback is gold for identifying real-world issues and prioritizing future development. Remember, RAG systems are not set it and forget it. They require ongoing refinement. Let's recap. RAG provides factual grounding by combining retrieval with LLM generation. Data quality, chunking, and vector store choice are foundational for success. Advanced retrieval techniques like query reformulation and re-ranking are critical. Careful prompt engineering, LLM selection, and output formatting ensure quality. Continuous evaluation and user feedback are essential for iterative improvement. The key takeaways: invest heavily in data quality and preparation. It's the biggest bottleneck. Don't settle for basic semantic search. Optimize retrieval with re-ranking and hybrid methods. Establish clear evaluation metrics and robust monitoring from day one. Build in user feedback loops to continuously improve your RAG system. Start simple, iterate fast, and scale deliberately. If you found this valuable, hit subscribe and the notification bell so you don't miss our next deep dive. Drop a comment with your experience shipping RAG. What were your biggest challenges and wins?